Alright, so today we're going to look at modeling quadratics. I'm going to do kind of two different videos on modeling quadratics. So make sure you check out the second one as well for kind of a different type of example. Alright, so first one here, and make sure you kind of write this down or print off the notes, to be able to do this. It says an astronaut standing on the moon throws a rock into space. The height of the rock is given by S of t, so S stands for height in physics. We use S as a height a lot of times for an object. So the height at any given time, so that's function notation, so S of t, is equal to negative 2.7 t squared plus 27t plus 6. Okay? So this is kind of a quadratic equation. You're going to throw the rock up in the air and the rock's going to come back down. Okay? So we got three questions that are going to be pretty typical questions about an object that's being thrown or launched or dropped or something like that we could ask you. Okay, so this problem is going to kind of cover all three types of questions we could ask. So the first one is, how much time will elapse before the rock strikes the lunar surface? Okay, so basically, how long is the object in the air? Okay, you throw it up and it comes back down, and I want to know how long until it hits the lunar surface. So we'll talk about how to solve that one. Okay. Second one says, how long will it take until the rock is 10 meters above the surface? Okay, so again, I throw the rock up in the air, goes up, comes back down. If you think about this, it actually is going to hit 10 meters twice, once on the way up, and then once back on the way down. So here's a case where we should get two answers for it. If the question asks you more specifically about how long until it reaches 10 meters on the way up, that's going to be different than the way down, and you can kind of understand you take the one that's the shorter time. It's going to obviously hit the shorter time to get up than it does to get all the way up and come back down. And then lastly, a pretty common question is, what is the maximum height of the rock? Okay, so what's the highest the rock gets above the lunar surface? Okay, so these are three very, very typical questions that we might ask you about a quadratic where something is thrown up in the air. So I'm going to show you kind of how to do these and how to analyze each of these three questions. Okay, so I'm going to kind of erase the questions so I have some kind of room to kind of work. Okay, the first question says, how much time will elapse before the rock strikes the lunar surface? Okay. All right, so first thing we got to know is, what does it mean to hit the lunar surface? Okay, if a rock comes up and comes back down, so here you are, here's my art skills 101, here I am on the lunar surface, here I am, okay, and I'm going to throw a rock up into the air. So it's going to go up and it's going to come back down. Based on this equation over here, what the 6 actually represents is the initial height of the object. Again, think about that. If time is 0, you get 6, which is your y-intercept. So this person, is 6 meters above the ground when they throw it. So the question simply asks is, how long until the object hits the ground? Well, when it's on the ground, it's at a height of 0. Okay, so you have to interpret what this question is asking you. It's basically asking you to find t when the position or the height of the object is 0. Well, S of t stands for the height. Okay, so I'm going to put 0 in for S of t. So I get 0 equals negative 2.7 t squared plus 27t plus 6. Okay? And now all I have to do is I have to solve for t. Well, this is a quadratic. It's set equal to 0. We talked about four different methods to solve. One, square rooting. Well, I've got a t squared and a t. Not working. Okay. One, factoring. I've got a decimal in the problem. I'm not even going to try. Could I maybe? Sure. I just don't want to touch that. Completing the square. Again, a decimal. A little bit tougher, although this will divide evenly, so I could maybe complete the square to kind of do that. But I'm probably, for story problems, just going to use the quadratic formula, just use my calculator and have it kind of crunch the numbers for me. Okay? So I'm going to use the quadratic formula. Instead of x equals, it's going to be t equals. So I get t equals the opposite of b, so negative 27 plus or minus square root of b squared. So 27 squared minus 4 times negative 2.7 times 6, all over 2 times negative 2.7. Okay. From here, just going to use my calculator. Okay. So grab my calculator and just kind of punch in the numbers. So 27 squared minus 4 times negative 2.7 times 6. That ends up being 793.8. So I get negative 27 plus or minus the square root of 793.8 over negative 5.4. So I'm going to get two answers. I could take the square root of that right now, and I could have done that all at once. So 93.8. That's 28.17. So I get t equals negative 27 plus or minus 28.17 over negative 5.4. Alright, so let's get my two answers. One is going to be negative 27 plus that answer. So negative 27 plus 28.17. Hit enter, and then divide that by negative 5.4. So I get negative 0.2167. Okay. Second one is going to be negative 27 minus 28. So negative 27 minus 28.17. Hit enter. Divide that by negative 5.4. 10.217. So what this is showing is there's actually 2 times that the object was on the ground. That's not realistic. It doesn't make any sense. Okay? But it does pictorially. So if I come back to my beautiful drawing here, okay, here's my y and x axis. What this first one is saying is that if it followed the parabola path, it actually would have hit the ground in the negative time, right before I kind of threw it. Okay? So it makes sense mathematically, but it doesn't make sense in the real world, which is one of the things we have to deal with. So we're going to nix that answer. And how long did it take for the object to come back to the lunar surface or come back to the moon surface? It took 10.217 seconds. Okay? So again, one of the things we're trying to get you guys to do is answer the problem. Okay? So the problem would say then it took about 10.217 seconds for the rock to come back to the lunar surface. Okay. So answer that in a complete sentence. So what does this mean? What does this 10.217 seconds mean? It means the object was in the air for 10.217 seconds before it came back and hit the ground. Okay? All right, so there's your first problem. So key thing, when it hits the ground, think about a height of 0, and S of t stands for the height at a certain time. Okay, so what this means is if I put 10.217 in for t, did the math, I should end up with S of t or of 0, so a height of 0. All right. Second question, asked how long until the object is at height of 10? Well, come back to my absolutely beautifully drawn picture here. This was at a height of 6. Height of 10 would be somewhere up there. Definitely not drawn to scale. Okay? But there's going to be 2 different spots where the object gets up to a height of 10 and then comes back down and hits a height of 10. Okay? So very similar to the other question, I just want to find the time, t, when S of t is 10. So S of t is going to be 10, so I get a new equation. 10 equals negative 2.7 t squared plus 27t plus 6. Okay. Again, I'm going to stick with the quadratic formula, use my calculator to kind of plug it in and get the answer. But in order to use it, I have to have it equal to 0. So the first thing I'm going to do is I'm going to subtract my 10 over. And this is how I'm going to get a different answer than before. So now I get negative 2.7 t squared plus 27t minus 4. Okay? All right, so now I'm going to use quadratic formula again. Same idea. T equals opposite of b, so negative 27 plus or minus square root 27 squared minus 4 times negative 2.7 times negative 4 this time, all over that negative 5.4, right? All over negative 2a. And again, I'm going to crunch some numbers with my calculator. I'm going to do this whole thing in here. So I'm going to take the square root of 27 squared minus 4 times negative 27 times negative 4. I'm getting 17.233. So I get negative 27 plus or minus 17.233 over negative 5.4. And again, let's get my two answers. So again, if I think about it, it hit the ground at like 10 seconds, so it's going to be, kind of close to 10 probably, and not too far afterwards. Since it started at 6, it probably didn't take too long to get to 10. So let's see what I got. So I'm going to take that number, negative 27 plus that, and then divide that by negative 5.4, so I'm getting 1.8 seconds. All right, and then let's try the other one. So negative 27 minus 17.233, divide that by negative 5.4, being 8.19. Kind of makes sense. There's some symmetry in there. You figure it was almost 10 seconds to get there, okay, on the ground, so I'm kind of almost some middle ground here around 5 seconds or so where that vertex is going to be. So I think these numbers kind of make sense as far as how close they are to 10 and 0. So there's some similarities there. Okay, so again, what does this mean? It means that the object reached a height of 10 meters at both 1.8 seconds and 8.19. So it took, so the object was 10 meters above the ground at 1.8 and 8.19 seconds into its flight. Something like that. Okay. So again, telling you that at two different times, 1.8 seconds and about 8.19 seconds, there and there, that's how long it took for the object to be 10 meters above. All right. Final question for this. Asks you to find the maximum height the object gets. Right there. I want to know how high this is. What's its height? What's S of t? Okay. Well, a key thing you should pick out from this is when it's at its maximum height, it's at its vertex. Okay, so I need to find the vertex, which again, I could use completing the square to do that, which wouldn't be a bad idea. But I also have that idea where I take the opposite of b over 2a. And that's how I'm going to find the x coordinate, or in this case, x is really t, because this is time and height. All right, so t equals the opposite of b. So the opposite of 27 is negative 27 over 2 times negative 2.7. All right, so it's going to be negative 27 divided by negative 5.4, which ends up being 5. So, what does this mean? It means it took 5 seconds for the object to reach its highest point. That's not its highest height. That's the time. That's the x coordinate. Okay? So, be careful on what the question is asking you. If the question is asking you how long does it take until the object reaches its highest point, then the answer would be 5 seconds. It took 5 seconds for it to reach its maximum height. This question actually wanted what the height was. Okay, so what I first did was use the vertex idea, opposite of b over 2a, to find the x coordinate. Now I have to find the position or the height of the object. So basically all I want to find is s of 5. So s of 5 is equal to negative 2.7 times 5 squared. This is just using function notation. Plus 27 times 5 plus 6. Again, use your calculator. Negative 2.7 parentheses 5, close them, squared, plus 27 times 5 plus 6. I have 73.5. So the highest object was 73.5 meters above the ground. So let's finish that up. So the maximum height the object reached was 73.5 meters above the lunar surface. Okay, so again, write that answer in a complete sentence. So the maximum height the object reached was 73.5 meters above the ground, or in this case the moon or the lunar surface. Okay, so remember there's going to be a second video on here of kind of another connection of using quadratics and how to model, so make sure you check that one out as well, because you're not quite sure what type you're going to get on the test.